Here we're asked to find all these solutions to the polynomial equation. So first of all, before I even start, I recognize that this is a fourth degree polynomial, meaning I should probably get 4 different answers, or that's the max that I could get. So when I'm looking at this, just to keep in mind as I go through. So first thing I'm going to use is figure out what the possible rational roots are. In this case, my possible rational roots are plus or minus 1, 3, 5, and 15 over just 1, because that's my leading coefficient. So basically, my all going to be kind of whole numbers, no fractions for my rational roots. I'll start with 1 because that's usually the easiest one and see where to go from there. So I'm going to use synthetic division to see if I get 0 at the end. So I multiply and I add, multiply and I add, multiply and I add, multiply, and this is not going to give me 0. So next I'm going to try negative 1, 1, negative 2, negative 14, negative 2, negative 15. I'm going to do this until I find one. I'll be quiet for a second so I can go a little bit faster. Okay, so for the first one that I found, I can see that x plus 3 is part of the equation from this. And then what's left over is x cubed minus 5x squared plus x minus 5. And then I need to do this again to keep going to see what works. So in this one here, I'm going to try 5 next with what's remaining. So now I'm just using the synthetic division between what's left over, not the original set of numbers. And this one here, I end up getting another one that works. So I'm now at x plus 3, x minus 5, and then x squared plus 1. And so now that I have it down to quadratic, I can actually just solve each piece. So x plus 3 equals 0, x minus 5 equals 0, and x squared plus 1 equals 0. And so I get my solutions here of negative 3, 5, and then I have to take the square root of negative 1, which gives me plus or minus I. So there's my 4 solutions, negative 3, 5, I, and negative I. So next one I'm going to be doing the same thing here, and just to find the possible rational roots, I got plus or minus 1, 3, 9, and 27 all over 1. And so I would go through and I would find which one works just for time's sake. I'd try 1, negative 1, 3, and then negative 3. And negative 3 ends up being the one that works. So you can see it here. So that means that x plus 3 is part of my equation. X squared plus 9 is what's left over. Now that I'm down to a quadratic, I set each part equal to 0 and solve. So I get negative 3. I take the square root of both sides to get plus or minus 3i. So in this one, because my original equation was cubed, I expect up to 3 answers. So I get negative 3, 3i, and negative 3i. And that's how we solve a polynomial equation.